grids is processed to detect the presence of an obstacle. So this is purely based on depth information. So if there is any obstacle within, let's say, 2 feet from the user, it will alert the presence of obstacle, saying, the obstacle is in the center grid, and it will also fit a cuboid to measure the size of the obstacle. In advanced perception, we try to understand the environment in a complex manner by performing image classification, object detection, semantic segmentation, and also perform deep learning classification for elevation and change detection. So far, we can detect people, car, traffic lights, traffic signs, and also crosswalk detection. Can also detect curbs and many other instances of objects. We had to collect a certain set of data set that is available online, as well as we had to collect some custom data set by walking along the neighborhood streets of Monrovia. So this is some data set, sample data set that is shown in this slide. The first data set was used to perform object detection and semantic segmentation. And this was collected near the downtown and neighborhood area of Monrovia City. And the curve data set was mainly used to detect the elevational changes from getting on from the road to the curve data set. For this, we collected around 8,000 to 9,000 images. For the other custom data set, we collected around 600 images. For the curve data set, along with RGB data, we also collected the depth information, depth image as well. Along with this data set, we also used the Google Open Image data set and LISA and German traffic sign data set. So our models were trained on all this data set. When it comes to models, we also trained our own custom models for object detection and elevation and change detection. And we tried to treat this problem as a self-driving car. So we took some of the Intel's OpenVINO's road segmentation ARS model, and we also experimented with OpenVINO's semantic segmentation models. And we also tried TensorFlow Lite deep lab models that were trained on Cityscape and the AD20K data set. The last two models, that is the semantic segmentation models and the TensorFlow deep lab models, were taking too much inference time, so we couldn't deploy it on the real-time usage. But however, we were able to obtain very good results with the road segmentation model as well as the object detection model from Pascal velocity dataset from OAK-D open source architecture. So this is our object detection pipeline looks like. Like I mentioned earlier, we are able to detect people, trash cans, and traffic signs, and even street signs, and so on. For this, we use two object detection model. One is pre-trained from OAK-D, and other is object detection model trained our custom data set. Since these are optimized model, they produce some false positives. So we trained another layer of background classifier, which can reduce these false positives to make sure the detections are valid. And this traffic sign, where we used another classifier called traffic sign net to classify whether they are valid detections or not. So these are some sample detection. As you can see, we are able to detect the traffic lights here, the traffic signs, for example, stop sign here. And we're also able to detect the yellow payments, particularly meant for visually impaired people. We're also able to detect public trash cans and some signboards here. Here we can also see the street signs being detected. And not sure if you can see it here. This is a road sign, which means for sidewalk closed here. So this is a sample output from the full perception stack that is running in real time. The system can perform up to 8 FPS. In this use case here, we are able to detect car, bicycle, and detect the traffic lights and also yellow payments. This is on the left column. On the right column, we're showing the performance of road sign, road semantic segmentation model. We're able to detect the road pixels and also extract the road markings from it. And using the road markings, we are also able to detect the crosswalks. So for crosswalk detection, we run the road semantic segmentation model. And this model can give us 4 classes, can detect the curb, road pixels, road markings, and the background. We extract the road markings from this. Once the road markings are extracted, we run image processing techniques such as dilation, calculate the aspect ratio, and eccentricity value. Based on this, we find whether it is a crosswalk or not. And the crosswalk detection is enabled only based on detection of stop sign. This is done because crosswalk detection might take more computational power. So we want to utilize computation power for running many other perception models in real time. So this is a feature that is activated only upon detection of stop sign. So when it comes to localizer, so the user can save the GPS coordinates of any location they prefer. This is something the existing maps don't provide. We wanted to have a feature that is different from the existing maps. So for example, if the user goes to particular locations often, let's say a grocery store, a Walmart, or ice cream store. So when they're at that location, they can request the system to save the location with their preferred name. It could be, Walmart, or it could be an ice cream spot, or it could be even a friend's place. And the coordinates can be saved using the voice command. The keyboard here is locate. When the user activates the system with the keyboard locate, the system will respond asking for the name for the coordinate name to be saved, and the system can then listen to the name of the location and can save the name along with the GPS coordinates. So in case of emergencies, if the user feels the user is lost, the user can request the system using the keyword locate. To save the locations, the keyword is save location. In case of localizing, in case of emergencies, using keyword locate, the user can request the system to locate themselves by using the save location. For example, the system can tell the user is so-and-so meters from, let's say, ice cream store, or so-and-so meters away from Walmart. And also, apart from this, the user can also send the GPS coordinates to the preferred contacts via SMS. Here is a sample snapshot of the sent GPS to the user. And we can see the GPS coordinates being listed in the SMS here. So one of the most important factors that we paid a lot of attention is the user interface. With the existing app, a lot of existing apps, the common issue is that the user is continuously bombarded with so much information. After some time, the user cannot focus on the app, so they end up not being used. So our focus was to keep the user interface extremely simple and present the information only as required by the user. And by default, we provide only critical updates, such as presence of obstacles. Apart from that, most of the other features are provided upon request by the user. For example, save location or then we have another feature, describe. So where the system can describe the surroundings by listing what is present in the environment by listing their location in a clock notation. I'll get to that part a little later. So the critical part is we don't provide a lot of information to the user here, and we're using wireless Bluetooth enabled earphones, and we use the speech recognition to interact with the system. So this is the feature that I was describing earlier. It's called describe mode. So upon requesting the system with the keyword describe, the system can tell where is what obstacle in a clock notation. So let's say there is a car onto the right side of the user, and it's being detected by the system. So this information will be translated to the user like this. It will be like car 1 o'clock. And this notation is derived from the analog clock notation. For example, the car is present on the right side, which will be translated between 1 to 3, 12 to 3 o'clock. And in this case, if it is 20 degrees, it will be translated to 1 o'clock. And this is a feature that is provided only upon the request by the user. And we can detect many things apart from cars. It can be person, or it could be traffic lights, or it could be yellow payment, or it could be a trash can. All this information will be conveyed to the user in the clock notation. So here's a small demo video that I'd like to show here. And again, this feature is upon request by the user. This is not enabled by the default. Yeah, as you can see, sometimes when I'm presenting on Zoom, this video doesn't appear well. I'm not sure how it came this time. Just to make sure. So what is happening in this video is the system is inferencing in real time, and it is also showing the detections. And apart from that, it is also describing what is being detected where using the clock notation that was explained in the earlier notation. And all this is being done in real time. Yeah. So apart from this, let's take a look at some limitations of our solutions. One of the limitations would be our models are trained on the data set that is collected by Monrovia. So it might not work well or generalize well for other cities. But however, the classes that is being addressed in our solution is very generic. And also we've utilized the standard data set that has, Google OpenImage, and Lisa traffic data set, and so on. There might be some compromise in the accuracy when testing in other cities. And since we are using Edge AI technology, and also we want to keep the solution simple, we're not using any GPU as such, right? So running heavier semantic segmentation models would be a challenge. And when it comes to user interface, since we're using a audio interface, one of the things the visually impaired person relies is on the audio cues they're listening. So using an audio interface might block that interface. The user might not be able to get the audio cues from the environment. However, we have a new iteration where we are using the bone conduction earphones. So the user can hear the sounds from the surroundings because the audio signals will be sent from the bone conducting interface. Apart from that, the system requires some power, like any other hardware systems. So it requires some kind of a power maintenance, and we would need multiple sensors. And another thing would be the field of view would be restricted by the field of view of the camera. The user might not be able to see to get the normal field of view. These are some major limitations of our applications. Yeah, thank you. Thanks for joining this talk today. If you have any questions for me, I'm happy to answer them.
Hey, thank you so much, Jagdish. It was wonderful. Yeah, we have a few questions coming up. Nisirin is asking, like, the cost of the entire system.
Yeah, that's a very good question. So, it's extremely important to understand that the unemployment rate is extremely high among visually impaired people, and they don't have higher income. So our goal is to reduce the cost, and also, our solution is open source. The code that we've developed already is available online, and we want to transform the space of visually impaired community by making this project as accessible as possible. The idea is they can take the entire solution for free, and they can buy the hardware themselves and assemble and get it working. So the cost would be, so we are using AGI devices, which are way cheaper than the GPU alternatives. We are able to get this solution working for around like $700 to $800 with one sensor, and we are constantly looking into reducing this cost. And based on our research, at least in the US, the community would be able to afford this system for that price. And again, this will be open source. We want to make it free so that anyone can assemble the system on their own. I see another question where it's being developed. Yeah, so I think it is a multifaceted question. One is it was developed using the data set from Monrovia. However, it should work for other cities. I developed this when I was in Monrovia. But however, we have team from a lot of other countries, from the US, from Canada, from France, and many other places. So it's a team of volunteers and people who are from various backgrounds, and the team also includes people who are visually impaired. So the next step would be to get our system tested by our own team members who are visually impaired and get their input, and optimize our solution as soon as possible in an efficient manner. We're also in the process of raising funds. We launched a GoFundMe app a couple of months ago. It's still an ongoing process.
Okay, thank you, man. We have Deepak asking, like, for your voice activated commands, is it like localized to other languages?
Yeah, currently we are using English. We don't have any other language being supported. But the beauty of this project is it's open source, right? And we want to welcome as many as developers as possible and contribute anything they want to. It doesn't have to be anything huge. It doesn't have to be software. It doesn't have to be mechanical. It doesn't have to be management. Anything that anyone might think can help, it's being welcomed. I'm hoping someone will join our team in future and maybe include a voice recognition system for other languages.
Hey, thank you very much, Jagdish. My name is Ashok. I have a quick question. Have you collaborated with any other companies in this project? Is there any other partners who are working alongside?
We don't have an official partner yet. We are looking into that. We have heard some very good responses from the companies like Intel, and we are also continually looking into expanding our partnership with other companies.
Oh, okay. So My point is coming from more from other startups, not the big companies. I'm part of NASCOM in India, so we have close to 120 companies who are being mentored by the Deep Tech Club. Right, I'm a part of the jury in that. There are some propositions which is coming somewhat overlapping and near to what you are actually doing. Right. So my question is, are you open to collaborate with other small startups or small, when I say small startups, a bunch of like 5 to 6 guys, hardworking guys from India. So is it something which you
Yes.
encourage?
Yes, actually, in last couple of months, one of our main focus has been, reaching out to advisors and talking to, startups. And we are one of the important things that we're focusing right now is how to make this project self-sustained and raise some funds that can keep us going for maybe like a couple of years from now. And our main goal is to keep this open source and make this solution as accessible and low cost as possible, right? But however, it's very idealistic. We need to come up with some kind of a business model that will help us keep us going for for long term. And we are looking into a lot of business models. This includes taking a slightly different route and provide some supplementary solutions or complementary solutions to what we're doing. But the focus would be to keep our solution, the software solution, to be open source. And we might have to come up with some kind of other dependencies for the project. Like, for example, we want to get rid of the vest that we have. We're working on designing a custom vest that is even more simpler, that cannot be purchased online. So things like that might be sold from our side. But the main goal is to transform the visually impaired people community. And for this, definitely need funds. And we are looking into startups and other business models.
Thank you.
Jagdish, what are the kind of typical questions like people come up to you when you give a demo of your system to them? Could you at least tell us what are the typical questions they come up with?
Yeah, well, one of the interesting questions they ask is, can this replace guide dogs, right? So that's a very tricky question. I usually tend not to answer that because AI are probabilistic problems. We cannot say for sure, it will work like how it is used, right? So the guide dogs are extremely good at detecting obstacles. They can sense things and they're very proactive. Especially the trained dogs are really good. However, the challenge with the guide dogs is that while they can detect and sense things, they cannot communicate the presence of objects. Sometimes they cannot tell where the obstacle is, and there is a communication gap in that way. So it's not 100% effective, but the guide dogs are also extremely useful. So there is a gap in terms of communication there. Apart from that, there is also good model support from the dog there. This is a question that's commonly gets asked, and I generally tend to keep it very high level and not answer them. And apart from that, the common questions would be if the system is being tested by actual visually impaired person. So far, it is not. I am the one who has tested this system so far, and I tested this by walking in the downtown area, which is a pretty crowded area. So our next immediate step would be to get the system tested by our own team members who are in Seattle at the moment. And I see one more question. Am I using TensorFlow here? Yes, we are using TensorFlow for one of our models here, which is being optimized by OpenWay now.
How about you? Looking forward, like this whatever setup you have done right now, you see it like growing into other fields of like disabilities, which could help people in who have other levels of disabilities with the system you have.
Can you be more specific? What do you mean by other kinds of?
Like if it's currently for the visually impaired, but like going forward, like if the system can be used for other disabilities.
We might, not in the near-term goals, because our team is a team of volunteer and more focused on addressing the visually impaired at the moment. But there are good chances that we might do it. For example, adding some kind of interface for people who cannot hear, right? We are looking into a different user interface. We already have a working prototype. It's a haptic-based gloves that can communicate the presence of obstacles using haptic gloves. So instead of audio cues, so this will already address people who cannot hear, right? So there will definitely be a lot of overlap there. But our main focus would be on addressing the visual impairment.
It's wonderful, man. Actually, what the contribution from your side, like to address one of the most challenging of disabilities facing mankind right now. Kudos to you for developing this setup. It was a wonderful and very, very informative session. And thank you very much, Jagdish, and all the people who have joined us. Going forward, we'll keep you posted in all the upcoming webinars from our side. Thank you.
Thanks for having me. Thanks for giving me this opportunity. It was nice giving a talk. There's one last question here. Is there PyTorch and the YOLO v3 models used? We have not used YOLO v3, but yeah, PyTorch, there are some models that's being trained on PyTorch and being further optimized using OpenWay. Yeah, sure, Ram, it was a pleasure. And thanks for giving me this opportunity. We look forward to extend this project, and hopefully we'll be able to scale and transform this community. That's our main motto.
Wonderful. All the best, and will keep us posted on whatever you go, you develop going forward. Thank you so much for your time. Really appreciate it, Jagdish. Thank you, everybody. Have a nice day.
Thanks, everyone.